go around long enough in the same direction, you wind up in the place you started from. Yes, Thomas?
Why don't we fall off when we walk underneath, Miss Sarah?
Because of a force called gravity.
What does gravity look like?
Gravity is something we can't see, but we know it's a great invisible force that keeps us all here on Earth. Some of you know what a magnet is, don't you?
I do.
I do.
Well, then let's think of it like that. Gravity could be called a kind of magnet. It's a natural force that keeps us all from flying off into space.
We were always told that the world is flat.
You were told right. Don't listen to her. I've been patient with you, Sarah. Lord knows I've been patient. But now your words have revealed you.
The law of gravity was discovered by Sir Isaac Newton in 1687. That's almost 200 years ago, Uncle Evan.
In 1687, Newton published his famous Principia Mathematica, which presented his idea of gravity to the world. The globe Earth theory had long faced criticism for being impractical due to the natural physics of spinning spherical objects, namely that anything placed on their surface should immediately fall or fly off. How could people, buildings, and the great oceans remain perfectly stuck to a ball Earth spinning faster than the speed of sound? The globe Earth theory needed a force that could keep everything in place somehow, a force strong enough to keep the oceans stuck to the Earth, but weak enough not to sink a sailboat. A force strong enough to drag the entire atmosphere along with Earth's breakneck speed, but weak enough to allow birds and bugs to travel freely and unabated in all directions. A force so strong it could make rain fall upwards and plants grow upside down, but yet so weak that it could not be detected by any contemporary methods. Newton's postulate of, quote, an invisible force able to act over vast distances led to him being heavily criticized for, quote, introducing occult agencies into the field of science. Previous to Newton's theory of universal gravitation, the natural laws of density and buoyancy already perfectly and adequately explained the world around us. For example, the reason a balloon filled with helium rises into the sky while a balloon filled with air drops to the ground is not because Newton's mystical pulling force has an aversion to helium, but rather simply because helium is lighter and less dense than the nitrogen, oxygen, and other elements which compose the air around it, so it floats up. And conversely, a balloon filled with your carbon dioxide exhalation is heavier and denser than the air around it, so it falls down to the ground. If you blow a dandelion seed out of your hands, a substance just barely heavier than the air, it will float away and slowly but eventually fall to the ground. If you drop an anvil from your hands, something much heavier than the air, it will quickly and directly fall straight to the ground. This is not because gravity prefers anvils to dandelion seeds, but rather because it is the natural physics of buoyancy for objects less dense than the medium surrounding them to rise, while objects denser than the medium surrounding them to sink. This is the reason raindrops fall down through the air and air bubbles rise up through the water, because of their relative densities. It has nothing whatsoever to do with the mystical pulling force of spinning balls from Newton's imagination. Newton's theory allegedly began when, upon seeing an apple fall from a tree at Woolsthorpe, as though no one in the history of humanity up to that point had ever seen a falling object and wondered why it fell, he had a veritable scientific epiphany. The apple fell not because it was heavier and denser than the air around it, but rather because a force at the center of the spinning ball Earth pulled it to the ground. Newton quickly got to work formulating his theory of universal gravitation, which he used to explain not only falling objects, but also orbiting celestial bodies. Newton claimed that the sun, moon, earth, planets, and stars' gravity caused them to all orbit around the most massive nearby bodies. So not only was gravity fickle and selective about which objects it caused to fall and which it allowed to rise, gravity was also able to perform different functions on different scales. At the human scale, gravity allegedly caused people, buildings, and oceans to stick to the Earth, while at the planetary scale, gravity allegedly caused moons to orbit around planets, and planets to orbit around stars. Unfortunately, Newton never addressed this, but the question remains, how and why would gravity cause both planets to orbit the sun and people to stick to the Earth? Gravity should either cause people to float around in suspended circular orbits around the Earth, or it should cause the Earth, Moon, and planets to all be pulled and crash into the Sun. The two effects are very different, yet the same cause is attributed to both. Furthermore, this magnetic-like attraction of massive objects gravity is purported to have can be found nowhere in the natural world. There is no example in nature of a massive sphere or any other shaped object which, by virtue of its mass alone, causes smaller objects to stick to or orbit around it. There is nothing on Earth massive enough that it can be shown to cause even a dust bunny to stick to or orbit around it. Try spinning a wet tennis ball or any other spherical object with smaller things placed on its surface, and you will find that everything falls or flies off, and nothing sticks to or orbits around it. To claim the existence of a physical law without a single practical evidential example is hearsay, not science.
Children, listen to me. Look around you. All around you. As far as the eye can see, the Earth is flat. Now you see it that way, because that is the way the Lord intended for it to be.